Okay, so this is the second type of advanced technique, which is trigonometric substitution. So I think the goal here is also to the same as the algebraic substitution. We still have to eliminate the radical expression, but I think in this particular technique is we'll be utilizing a different approach. So probably you're going to encounter this one um, if let's say the format for the inverse trigo function was not achieved. So again, let's try to recall some inverse trigo formulas. So we have integral of du all over square root of u squared, or rather a squared minus u squared. Then the other formula, di ba, 3 ram to kabok, di ba? So a squared plus u squared, and then the last one would be du all over u square root of u squared minus a squared. So if these formats are not achieved, so usually if you're encountering these particular expressions, diba? So as you can see in the integrand, diba? So it's more likely an inverse sine function, diba? This one is more likely a inverse tangent, but di siya pwede ma-inverse tangent because you have the square root. This one is more likely the same as the inverse second, but there's no u outside, diba? So, for example, you were not able to achieve the format for the inverse trigo function, meaning you haven't achieved these formats. So this is this is the purpose of this technique. So if dili siya pwede ang inverse trigo function, so we go straight to trigonometric substitution. As long as these terms are present in the equation. Okay? So you have a squared minus u squared, square root of a squared plus u squared, square root of u squared plus a squared. So I think it's not difficult to remember because they are just similar to the inverse trigo function. But of course, inverse trigo functions are formula based compared to this technique. So formula based gyapon siya, but we still have to identify first the expression in the integrand before utilizing a specific trigonometric substitution. So for example, you have this expression, square root of a squared minus u squared. So you're going to utilize this trigo substitution. So if it's in this expression, tangent, and then expression is second. So mura siya the same as the inverse, diba? But it's just in the inverse, it's arc sine theta, arc tangent theta, and arc secant theta, diba? So I think dali siyang memorize, diba? Or it's easy to recall because again, it's similar with inverse trigonometric functions. So if para ato masabtan na to ang i-discuss for you to be able to understand what I'm talking about, like dili ma-achieve ang inverse trigo function, you have to observe for the expressions in the given equation before utilizing the trigonometric substitution. So if you're going to look at these examples, diba? So let's say number one. So for number one, we can see that you have the square root of 16x squared, diba? So it's better siguro if you're going to have it in this manner, diba? So if you have it in this manner, so automatically you can just use arc sine, diba, in the final answer because it's let's say arc sine x over 4 mas gani. But notice that there's an x variable in the given equation. So meaning it is not following the format of the inverse trigo function. Same as the second example, diba? So you have here a squared plus u squared, but it's under a square root. Our formula for inverse tangent is just du all over a squared plus u squared. Diba? So number 3, so you have here u squared minus a squared, but it's in the numerator, di ba? It's not in the denominator. So better siguro if it's x square root of x squared minus 25. So we can have the inverse second function or arc second na inverse function. So same here. So plus gyapon siya, but it's under a roof, di ba? It's under the radical expression. And apo dyan variable nga x, sobra nga x, di ba? So same here is number 5. Almost correct for inverse triangle function, u squared minus a squared, but on the outside is you have x squared. But for inverse triangle function, it's just du all over u square root of u squared minus 4. Diba? And it gets even complicated. Look at number 6 to the power of 3 halves. Diba? So if in radical expression, that would be the square root of x squared plus 1 and then cube, di ba? So samot kalabad ang o, di ba? Kung saan na siya pag integrate. So again, going back to the previous slide, so you have to be mindful of the given expressions first. So these 3 expressions. So 3 lang because of course the counterpart of the inverse functions are also 3, di ba? So kanira siya inyong mga pangitao na expressions. If inverse functions is not attainable or is not possible. And then so after determining the expression or observing the expression, so you go to the formula. 3 formulas. So it's not really a formula, but it's a sub-formula that we're going to use in the process of the trigonometric substitution. Okay, so let's try the first example para ma-appreciate ninyo ang steps. So again, observing the radical expression. So again, overall, in totality, looking at just the equation, I can say that I cannot achieve it using inverse triangle function, di ba? So next is we observe the given radical expression. So this is in the format of a squared minus u squared. So by formula, this is u is equal to a sine theta. All right. So we try to declare the different variables. So a is equal to 16, u squared is equal to x. So a is 4, and then u is equal to x. Okay, so this time, after declaring such variables, we're going to use the formula. So u equals a sine theta. So this becomes x, that is the u parameter, and then a is 4 sine theta. So this is where we get our derivatives. So notice that we have dx, di ba? So we're going to get dx from the substituted formula. This one, dx. So dx is equal to 4 cosine theta. Okay, so notice that I can replace x, I can replace dx. So let's try to put some arrow, huh? So again, dx is here, and then the x variable is here. So what's left for us to replace is just the square root of 16 minus x squared. So we are going to look for 16 minus x squared. So atong button is, again, we utilize the formula and try to isolate the trigo function. So what do I mean by that is, ngayon mo na siyang sine theta is equal to x minus 4, diba? Isolating the trigonometric function. And after isolating, I'm going to create a right triangle. Na mag-drawing na din pita. So for example, this one is theta. And again, sine function, diba? X over 4. So again, by basic terms, opposite side all over the hypotenuse. So 4 is the hypotenuse, opposite the right angle. Opposite the angle is x. And the unknown side, of course, by Pythagorean theorem, that would be the hypotenuse squared minus one of the legs squared. So this is 16 minus x squared. Okay, so next step is you are going to get a specific trigo function that involves the radical expression and the constant term. So what particular trigo function that we can use for us to relate the radical expression and the constant number? So this would be cosine. So cosine theta is equal to, again, adjacent side all over the hypotenuse. So that would be square root of 16 minus x squared all over 4. Then isolating the square root, or the radical expression, I mean. So 4 cosine theta is equal to 16 minus x squared. So notice that we can now replace it with this term. Okay, so upon observation, if we now substitute the different parameters, notice that all our variables are in theta now. So dx is 4 cosine theta. So kuha ni siya, napa ni siya d theta de. Sorry. So 4 cosine theta d theta, then divided by x squared, that would be the x parameter for sine squared theta. Di pa siya squared eh. Okay, it would be wrong if we directly eliminate squared para ma-emphasize ang pag-distribute sa square later on, sa 4 and sa sine theta. Then lastly is the square root. You have 4 cosine theta. So again, notice that all our variables are now in terms of theta. So cancel out 4 cosine theta, cancel out 4 cosine theta, expand the square function. So this leaves us with d theta all over 4. Rather, it's 16. It's not 4 there. So this one is 16 sine squared theta. So in other terms, we can express this one as 1 over 16. And then instead of 1 over sine squared theta, we can have it as cosecant squared theta d theta. Diba? Sakto, diba? Okay, so integral of cosecant theta squared is negative cotangent theta plus c. So is this our final answer? So it's not yet our final answer since this one is still in terms of theta, and our given variable in the given expression is in terms of x. So we need to go back, or we need to utilize again the triangle for us to be able to know what is the value of cotangent. So cotangent, so let me write in another ink. So cotangent theta coming from the right triangle. So again, cotangent is adjacent side all over the opposite side, diba? So katuwa, so tuwa is opposite over adjacent. If it's cotangent, may mo siyang ka may mo siyang tao, diba? Tao, kotao. So this is square root of 16 minus x squared all over x. So this will give us negative 1 over 16 times square root of 16 minus x squared all over x plus c. So the final answer would be square root of 16 minus x squared all over x, rather 16x plus c. So this would be the final answer. All right, so questions for the first example. So before you ask questions, so let's try to summarize what we did. So this will be the first step. And then the second step, so first step is identifying which formula you're going to use. And then second step is use the formula and get the derivative. The third step is to isolate the given trigo function for us to be able to create your triangle later on. So next step is upon getting the triangle, so get the corresponding function by pairing up the radical expression with a given constant. So of course, number 5 would be the substitution part. So replace everything. So keep in mind that everything has to be in theta parameter. So from x going to theta parameter. Then the sixth step is of course this one. Replacing back again the value of theta, replacing theta to x again. So 6 different steps. Yeah, I think these are repetitives, repetition or recurring steps with each problem that you're going to answer.
May I ask, sir?
Sige.
Ah, sa final answer, sir, ba, na wala lagi ang negative?
Negative din na siya. So it's negative then, negative. So thank you for that one. Okay, so any other question? So I think it's pretty clear man sa, di ba, ang pag-present sa solution. Okay, so I think there's no further question. So let's try to proceed to the next example. So you have here the integral of dx all over x times square root of 9 plus x squared. So again, in this, the format given is the same as a squared plus u squared, diba? A squared plus u squared. And this gives us the arctangent, rather the u equals a tangent formula. Okay, so next step is to declare the variables. A squared is 9, u squared is x. Get the square root of both sides. A is 3, and then u is x. So next step is you utilize the formula. So this gives us x equals 3 tangent theta. Then getting the derivative, you have dx is equal to 3 secant squared theta d theta. Third step, isolate the trigo function. Tangent theta is equal to x over 3. So fourth step is we create the right triangle. And again, we pair up the radical expression and a constant and look for the possible or the trigo function for the pair up. So tangent is opposite side of the angle theta and then adjacent side is 3. So this is square root of 9 plus x squared. So again, this one is square root of 9 plus x squared because again, it's a right triangle and we are just following the rules or the theorem by Pythagorean, di ba? Pythagorean theorem, c squared is equal to a squared plus b squared. So again, the fourth step would be this one, to look for a certain trigo function that relates the radical expression and the given constant. So this one is cosine. Cosine theta is equal to 3 all over the square root of 9 plus x squared. So rearranging by isolating the radical expression. So this gives us 3 all over cosine theta, or in other terms, this one is 3 secant theta. So again, if we try to review what we did. So again, step number 1, step number 2, step number 2, step number 3, then this is step number 4. Diba? So also, if you try to observe the different items in the given expression, so all can be replaced by the following terms, diba? Okay. So replacing the terms now, this is the fifth step. So dx is 3 secant squared theta d theta divided by the x parameter, that would be 3 tangent theta, and then the radical expression is 3 secant theta. Okay, so eliminate 3 secant theta, eliminate 3, and then 1 secant theta. So this leaves us with just secant theta d theta all over tangent, rather 3 tangent theta. So if we try to further simplify this one, so take 1/3 outside. Secant theta is 1 over cosine divided by tangent theta is sine theta all over cosine theta. So cancel the denominator since they are the same. And then what's left is just 1/3 integral of 1 over sine theta, which is just equal to 1/3 integral of cosecant theta, d theta. Okay, so by formula, so if you try to recall the formula for cosecant theta, this would give us 1/3 ln of cosecant theta minus cotangent theta plus c. All right. So again, if you try to again use the sixth step, so let me write it here. So cosecant theta is equal to, so again, cosecant is hypotenuse all over the opposite side. So this would give us 9 plus x squared all over x. For cotangent theta, that would be adjacent side all over the opposite side. So since there's no space now, so let's try to, so I'm going to simplify it directly. So 1/3 ln of, so ln of square root of 1 plus x squared minus 3. Okay, since both have the same denominator, so I can just group together the numerator, diba? Plus c. So this would be the final answer. So again, this is the sixth step. Okay, so a question. Okay, so I think there's no question. No question. Sure, Najid? Sure, Najid? Okay, so having no questions, let's proceed to number 3. So katong continuation is ako tong gituyo lang eh basta niya mulapas ang ako ang solution ba. So again, looking at the given expression, this one is u squared minus a squared. So variable squared minus constant squared. So u squared minus a squared is equal to, so our given formula would be u equals a secant theta. So again, our a squared would be, or rather u squared first, would be x squared. A squared would be 25. So u equals x, and then a is equal to 5. So next step is we utilize the formula. So this would give us x equals 5 secant theta. So getting the derivative, dx. So derivative of secant, that would be secant theta tangent theta d theta. All right. Then next step is we try to isolate secant. So secant theta is equal to x over 5. And then draw the right triangle afterwards. So again, secant is hypotenuse all over the adjacent side. So x here and then 5 here. So meaning the other leg by Pythagorean theorem, x squared minus 25. So again, we pair up the constant and the radical expression. So we can see that it's tangent, diba? Tangent theta is equal to the opposite side x squared minus 25 all over the adjacent side, which is 5. So isolate the radical expression. 5 tangent theta is equal to the square root of x squared minus 25. Okay, so Kira. So far, step number 1, step number 2, so probably step number 3 and 4 is can be together, diba? After isolating the radical, I mean, after isolating the trigonometric function, you can just draw the triangle afterwards. And this is step 4. Okay, so for step 5, we have to replace or do the substitution method. So again, if we try to locate the different terms here, everything can be replaced in the equation. So this one is going towards here. Dx is x is here, and then dx is still the same. Narasolvus x. Okay, so numerator is 5 tangent theta, then divided by x, which is 5 secant theta. Then our d theta is 5 times secant theta tangent theta d theta. So cancel out 5, cancel out secant theta, and what's left is just the integral of 5 tangent squared theta d theta. So you may place the constant outside. This would give us 5 integral of tangent squared theta d theta. So if you're trying to remember what are the formulas for the basic trigonometric functions, so there's no such formula for tangent square theta, diba? But we can still solve this one because we have atong three different types, diba? Three different types, diba? Type A, type B, and type C. So this one is type B. So I think it's case number 1 since the exponent is even. So I don't recall if it's case number 1 siguro to ang even or ang case number 2 to ang even. So basta type B ni siya, type B. Okay, so what we can do here is we're going to utilize the Pythagorean identity by replacing tangent squared theta with its corresponding identity, which is secant squared theta minus 1 d theta, diba? So having two different integrals now, and then the other one is just 5 integral of d theta. So there's a formula for integral of secant squared, diba? Which is just tangent. And then this one is 5 theta. 5 theta plus c. Okay, so going back to the triangle, so tangent theta, di ba? Namatay tangent theta. Yeah. Timingan pa jud, it's 5 tangent theta pa jud, di ba? So automatically this one is equal to square root of x squared plus 20 minus 25. So how about for theta? Where do we get theta? So we get theta by using the formula. So secant theta is equal to x over 5. So di ba kanang pinacalculator, if we are looking for the angle, we tend to get the inverse, diba? Katong, sige na siyang function, katong tangent to the negative 1. So, mura po na siya. So, this becomes theta is equal to arc secant, diba? That's the inverse. Arc secant x over 5. So, meaning our final answer would be square root of x squared plus, rather minus 25 minus 5 arc secant x over 5 plus c. So that's the final answer. And just let me write the sixth step here. This is the sixth step, replacing back the value of our um, theta variables. All right, so question? Questions or clarifications? So I think there's no question, so let's proceed with the fourth example. So sige lang, 3 more examples lang ta. So 4x squared, so again, this format here. So in the last 3 examples, so let me try to kanang ko na lang. Hindi na ako mag-put og mga steps ha. Ako na siyang i-kuha na para di ta maana daw kasi put ang numbers. So this is u squared minus a squared. So again, the formula here is arc secant. It's not arc secant, but rather secant. A secant theta. So u squared is 4x squared. A squared is 9. U is equal to 2x, and then a is equal to 3. So again, utilize the formula. That would be 2x equals 3 secant theta. Dito siya secant eh. It's plus man din, no? So it's tangent eh. So this one should be tangent. Okay, so before we try to integrate this one, or rather derive, so let's isolate x first. So this becomes 3 halves tangent theta, and this is the time we're going to derive this one. So dx is equal to 3 halves secant squared theta d theta. Okay, so again, isolating the trigo function. So this would give us tangent theta equals 2x all over 3. So using the right triangle again, theta, and then this one is the right angle. So 2x, 3. This is the square root of 4x squared plus 9. So again, pair the radical expression and the constant with the given trigo function. So there's one tip here, di ba? We can use basic trigo functions, sine, cosine, and tangent. But if you try to look at the formula, and then the process that we have done throughout the first three steps. So we are dealing with tangent, diba? Tangent, tangent, and then we're dealing with secant. So instead of using secant, or rather cosine, I'm going to use secant because I am seeing a secant in the dx term. So the purpose of me using secant, so probably later on, it will be eliminated in the process, diba? Secant studied so. So basin if cosine, I still have to convert it into secant and I have to do some additional steps for me to be able to do that, diba? So secant theta, so that would be the hypotenuse, 4x squared plus 9 all over 3. So this is equal to 3 secant theta, ang inyong 4x squared plus 9. So again, the purpose of me using secant theta, so again, this is a hint or a tip. So whatever is the majority in your first three steps, so just try to use that trigo function in declaring other trigo functions in the process. Para at least later on, once you go to the substitution method, the elimination will be easier or the simplification process of your equations will be easier. All right. So let me use the red ink. So again, x dx, and then square root of 4x plus 9. Or rather, it is on the second line there. So integral of, again, this is 3 halves secant squared theta d theta all over the x parameter, that is 3 halves tangent theta, then multiplied by 3 secant theta. So notice that we can eliminate, diba, ang secant ritso. So this leaves us with 1 secant function in the numerator and then 3 tangent theta in the denominator. So again, we can isolate the constant. Then, of course, in this particular next step is I think we can dissect again secant and tangent. So 1 over cosine theta divided by sine theta all over cosine theta. So don't forget the d theta. So cosine theta, cosine theta. So what is left now is just the integral of d theta all over sine theta. And this is just equal to 1/3 integral of cosecant theta d theta. So I think it's the same as number 1, or number 2. So the integral of it is 1/3 ln of cosecant theta minus cotangent theta plus c. Okay, so cosecant theta, that's hypotenuse all over the opposite side. And then cotangent is equal to, it's just adjacent side all over the opposite side. So this should be 3 all over 2x. So final answer would be, so I'm just going to group together the answer. Okay, there's no more space. 1/3 ln of the square root of 4x squared plus 9 and then minus 3 all over 2x. plus c. So that would be the final answer. Okay, so let's move on with the next example. Okay, since there are no questions. So again, observing the radical expression, this is the square root of u squared minus a squared. So this formula would give us u equals a secant theta. So u squared is just x squared, a squared is 4, and then u is equal to x, a is 2. So utilizing the formula now is we have 2x equals 2 secant theta. So getting the derivative dx, this gives us 2 secant theta tangent theta d theta. Okay, then again utilize the formula by isolating the trigonometric function. Secant theta is equal to x over 2. Okay, so then draw the right triangle then afterwards. So secant is hypotenuse, or rather it's hypotenuse x there, then adjacent side 2. And this becomes x squared minus 4. So pairing up the radical expression and a constant with a particular trigo function, so we use tangent. Tangent theta is equal to opposite side all over adjacent side. So this would give us 2 tangent theta is equal to the radical expression square root of x squared minus 4. So medyo paspas na siya because the process is repetitive, di ba? Okay, so dx is 2 secant theta tangent theta d theta x squared. That's 2 secant theta squared. And then the radical expression is 2 tangent theta. Okay, so cancel out 2, cancel out tangent. So this one is 4, this one is squared. So cancel out 1 second and then cancel out 1 second in the denominator. So this leaves us with d theta all over 4 secant theta. And this simplifies further to 1/4. So 1 over secant is just cosine, diba? So the answer would be 1/4. So integral of cosine is the basic formula, sine theta plus c. So again, looking at the right triangle, sine theta is opposite over the hypotenuse. So that would be x squared minus 4 all over x. So final answer would be 1/4 times the square root of x squared minus 4 over x plus c. So multiply. Final answer is square root of x minus 4 over 4x plus c. Now, so questions? I think there's no question. So let's try to proceed with the last example. So last example na kay gutom na no. Okay, so in this last example, so even though that you have 3 halves here as your exponent, so if you try to recreate this one in its exponential expression, or rather radical expression, so this one is, so again, the denominator is the root function. This one is the exponent, diba? So this becomes the square root of x squared plus 1 and then cube, diba? So in this particular item or problem, just try to ignore first the 3. So we focused more on this format first. So kanang to the power of 3, we'll deal that one later um, once we reach the fifth step, which is substitution. Okay, so if we try to identify this format, this is just equal to a squared plus u squared. So kung ano lang siya, na-interchange lang because again, commutative property of addition. A plus b is just equal to b plus a. Okay, and then the formula is just u equals a tangent theta. So a squared is 1, u squared is x squared. So a is equal to 1, and then u is equal to x. So formula is x equals tangent theta. Getting the dx, the derivative, this gives us secant squared theta d theta. Utilizing again the formula by isolating the trigonometric function, this gives us x over 1. And then create the right triangle. So opposite over adjacent side. So this gives us x squared plus 1. So again, pair up the radical expression with the constant given. And again, upon looking at the different functions that I am encountering tangent and secant. So instead of using cosine, I'm going to use again secant theta. And this is just equal to x squared plus 1. So over 1 siya, but wala na kayo butang over 1 because it will be repetitive, di ba? So, wala siya. So since we are done declaring different stuffs, so this is the next step, substitution. So secant squared theta d theta. So again, instead of to the power of 3 halves, so since we have here square root of x plus 1, so this becomes secant theta, then cube, di ba? Then cancel, cancel. What's left is just d theta all over secant theta. And simplifies further to cosine theta d theta. And we have here sine theta plus c. Okay, so sine theta, looking at the triangle, is just x all over the square root of x squared plus 1. So final answer would be x all over x at the square root of x squared plus 1 plus c. So again, since the radical expression in the denominator, so we need to simplify this through rationalization. So the final answer would be x times x squared plus 1 all over x squared plus 1 plus c. So this would be the final answer. All right, so questions or clarifications for the last item. So again, if you have exponents fractions, so just try to revert it into the radical expression and then just try to ignore the exponent nga kuan. Ang katunan sang a squared plus u squared lang sa ang inyong iatiman. Yeah, excluding the exponent. Okay, so questions or clarifications?
None from me, sir.
None, yes, sir.
Okay, so if there's no further questions, so again, just try, the assignment will be open at 12 man siguro. Then I'll try to upload the recording as fast as I can para inyo siya mabuhatan ng assignment. Okay, so again, there will be succeeding assignments also that I have posted, integration by parts and integration by partial fractions, which will be discussed on the next meeting. So again, be mindful that the midterm exam will be on the 26th of March. That would be on Saturday from 1:30 to 4:30. So just try to, again, start reviewing your lessons from the beginning up until this point. Para next week, ito na lang last two remaining topics na lang inyong tunan. Alright, so if there's no question, so that's it for this meeting. So see you all on Monday.